All right, let's go, let's go, let's go, let's go. We are back in cryptography and we are figuring this out. So, what do we got? What do we got? We have our signing key, which we're going to rename from JWT to key signing. Um, just messing around right now. And then we will pass it down here. So let's just see where else are we using that value. So keys signing, keys encryption. Right, so we're going to pass the encryption key to the uh, we're going to pass the encryption key to the encryption stuff, and we're going to get it by um, we're going to get that key by doing some, you know, fun stuff in cryptography hazmat. All right, let's see where we're at here. Okay, so let's make this full screen. Okay. Need a little bit more room there. All right, what do we got? So private key generate. We don't want that. Public key generate. We don't want that. Private key exchange. Pure public key. Shared key. Okay, that might be relevant for us. No, probably won't actually. Um, because we don't care about the public portion right now because we're only using for encryption. So derived key, derived shared key, private key, dot exchange, pure public key. Okay, generate private key, generate private key exchange, pure public key. Okay, let's pull up Filippo's go code go code again. Let's take a look at them side by side. Okay, what do we got here? And let's make sure that we attribute appropriately. BSD3 clause. Fantastic. References. I like to put references here, so we'll say this is where we got it from. Okay, so what are we doing here? File byte. So recipient. What do we got here? SSH key, public key, their public key. Okay, so we are encrypting for someone else's public key in this case. So this is the case we're encrypting for someone else's public key. Derived key. Yeah, this is dangerous. This is dangerous stuff. All right, well, we will flag this for hello review. Boom, to do security hello review. Done. Okay, so generate a private key, please. Exchange. So what do we have? What we have are, where are we choking here? Export private. No private key available. Okay, yeah. So, okay, import from PEM. So it can only import the public portion here. So why is that? So import from PEM, host key. So let's look at JW Crypto. Okay, so XLI key exchange. Okay. Curve. Okay, let's maybe look at the private key interface itself. Public key, private bytes. Allows serialization of the key to bytes. Okay. From private bytes. Loaded as raw. For encoding. Class method for loading. Encoded as raw. Raw. A raw format used by X448 key exchange. It is a binary format and invalid for other key types. X44 key exchange. This looks very similar. So what does blog post say? Danger. Okay. First we need to understand the difference. Okay. Where is his comment within? I know he had a comment within this code that references his blog post. Let's find that. Here it is. Okay. Bytes Montgomery. Okay, so ED public curve. Where is this used? References. New ED recipient. Okay, MKP, their public key. Okay. SSH public key is not an ED, so we have an ED key, and we're trying to take it to curve 25519 MPK. So this recipient, where is it used? Okay. Age recipient. Okay. What is this? Same thing. Okay, recipient. And recipient is where we're calling wrap. Okay, so, okay, I see. So basically, we come in here, we create this new recipient object. Um, we create a SSH key. Okay, so we have a SSH ED25519 key, correct? That's what we have as well. Um, we're looking for, PK does not implement SSH crypto public key. Oh, are we just encrypting it? We need the private portion. Public key to curve. 519. Okay, but can we do ED25519 vet key to X25519? Okay, yeah, okay, there's the blog post again. Okay, this is use case, example code. Hey, this is they know what the hell they're doing. We're in the right place. We do not recommend you do this. Should never be reusing keys. Potentially bad practices. Oh, this is written in Rust. Okay. Okay, yeah. Hmm. Yeah, well, we don't want to, well, we want to reuse a key only because this is all we've got right now. And we need to, let's see, how could we do this otherwise? Okay, so we have a key. So we create a DID. The DID says, I own public key X. Maybe we could just have the key sign the DID and then verify it in another document. I really want to do it this way. Do not recommend you do this. Should never be reusing keys for both authentication and encryption. Okay. They want us to use two different keys. So what if we just used two different? So signing, hmm. So what if we just generate a JSON web key? Will it do it for us? Okay, generate. Let's try this. Well, I know we should listen to that. I know we should listen. You don't go around not listening to ISIS, she knows what she's doing. They know what they're doing. Yeah, I'm pretty sure they work on all of the crypto stuff. Yeah, we don't want to go against their recommendation. Ah, damn it. Okay, fine. All right, you know what? Let's just go this other route. Let's make sure we document where we landed. Okay, so this is basically, you know, it's fine. I want to go do it now, but we'll leave it to somebody else who wants to make bad decisions. It seems like a really fun thing to do, though. Okay. All right, reusing keys is not fun. Reusing keys is bad. As fun as it sounds. Yeah, and so why don't we reuse keys? I'm sorry, I should have explained that. So why don't we reuse keys? And what are we being told to do here? So we're being told to generate some new keys and then basically, figure out a way to link them back to the old keys. So why was I so hell bent on using the same key? Um, because the it could just be like this because we could have had parity with the DID key. Like we could have had the same key. Like if we could have used the same key. So basically I could look up on GitHub without being told. Or well, I guess I have to be told to go to GitHub anyways. So, I feel like there's something there, but I guess there's not. So whatever. We'll give up now. All right, let's make sure this goes cleanly. Did not go cleanly. Okay. To do, these keys are not quantum safe. C, what was that spec called? It was called Curie. Okay. JW crypto dot JWK dot okay. Keys encryption. JW Okay, there we go. So keys encryption. Let's see what happens. I still spelled it wrong. I don't like that key. So why don't I like that key? Create multi-base, no malgo 2 as suspected. 647. Okay, so that must be here. 647. So here. Okay. Cannot concatenate stir not JWK to stir. So maybe we need to do, maybe if we did JSON or dot export. Invalid JWK key type, key agreement expected. Okay, let's go check it out. Key agreement expected. Let's maybe just try this, see what happens. Didn't like that. Let's try this, see what happens. Didn't like that either. All right, key agreement expected. So I have a feeling JSON web key is the right kind of thing if we pass a JSON web key. Verification material format PID format. So JWK value. Okay. But it likes taking the other one just fine. So okay, so let's dive. Okay, verification agreement curve does not equal x259 EC curve. Okay, so yeah, duh. X25519. Okay, so JWK has no attribute name. Yeah, we do need to do export. Hmm. Okay. Generate per key. It's not happy when generating now. All right. We lost the fight against the dragons. Let's go to JWK. Let's check out the generate. See what kind of docs that has. Generate. Okay. OTP, OKP, stir, one of. Okay. That's what we've got. EC. Generate. Why is generate not linked? grep rn generate. All right, let's look for generate. Okay, here it is. So KTY. So what do we have? We have KTY EC, KTY oct, KTY RSA, KTY EC, generate KTY RSA, generate EC, generate OKP, OKP, OKP. One of, okay, so it looks like this is a OKP. So KTY should be OKP. And then there's our curve. Boom. All right, finally. Okay, so what would we do if we wanted to link these to the SSH keys? How would we do that? So we could say I have an SSH key. Thing is, we want the SSH keys to sign so that we know it's the same key. So the whole point of that is using the same key. Okay, so this works. All right, so it works with us generating a key. Okay. So if we take that, okay, so what if, okay, but I want to do it, I still want to do it, I still want to do it, I still want to do it. I can't help myself. I can't help myself, we're doing it. So what do we have here? So, man, I want, okay, how can we do this without doing this? You could have the SSH key sign some blob and then a DID method, and then a DID. You can have an SSH key. Yeah, I'm sure you can do it. Oh, this is just so much easier. Creates from an ED public. Ooh, from a private key, that's the one we want. Sample ED shot top signatures, signature scheme, new key pair none, wrap. Okay, version key to key exchange, sign key to key exchange, sign key to key exchange. I guess normally 64, we only need the secret from the first half. That's kind of sketchy. or I guess the secret is only in copy from slice, clamp result, hash secret. Mm, I want it. Hmm. We're gonna do it. So sign key to exchange. Verify key to exchange. Verify key to exchange. Okay. 2 Montgomery as bytes. 2 vec. Alright, so we read it and so we do what? From bytes, verify it's valid public key. Compressed Edwards Y. Okay. Verify key to key exchange. Okay, but sign key to key exchange. Private key result, private key. Okay, private key, secret 2 bytes. 2 vec. Okay, looks like some kind of macro. Okay. Expand any key pair from the input key used to arrive at complete key pair, expand key pair. Signature scheme. Feature X, proc key X, X, create new keys, load keys, verify, sign. Okay, whatever. Ooh, wait. Let SK. There it is. Hmm. Hmm. Just a taste. What is this hyperlayer Ursa? Private key. Hmm. So if we could use this code, we could decode public key. So Python cryptography uses the Rust code. So there must be a good way to do this, probably through the new wheel packaging. Sign to key exchange. Yeah, you look like a very nice function to call. So we want to call you. Let's see. Where is public key defined? Private key. Public key, so basically ensure that this public key is what we think it is, ensure the private key is what we think it is. Private key. Okay, so basically this is saying how is this thing encoded? So if we can encode the same way, then we can pull out. We'll end up with this. We can end up with this. If we start with something that is in this format, we can end up with something in this format, and then we need to figure out how to decode. So what format is this? Hex encode. Public key, private key, public key. Okay, private key, public key. Okay, what other methods do you have? Or functions, whatever. Okay, private key, SK, key exchange, unwrap. What are you? Center key exchange, result, private key, duplicate. Private key, private key, private key, private key, private key. Oh, I guess this is some kind of interface, isn't it? I don't know, Rust. Private keys, public key, is private key, public key, uses keys, private key, public key, uses keys is probably an encryption. Where were we? Keys, keys. Okay, private key. Implementation is a byte array. Okay. So back to my other question about how do I get this thing out of a byte array and what is it? How do we know what format this thing is in? IKM. Use to verify complete from the predetermined secret. Okay. Predetermined private key. I'm obsessed with this because we have no way to root trust without this right now. This is the fastest way, I think. So these are just byte arrays. So these are the raw key type, whatever raw key type is. So if we can get that into the raw key type. So where was the JSON web token? Import from PEM. From JSON. Okay. So these are some kind of, it's bytes. Don't understand what the format is. It's some kind of bytes. So maybe, but this is a hyperledger thing. So maybe there's some kind of to JSON web token or JSON web key. No code. right, JSON representation of master secret. Chain key. Sorry, JSON. Let's see what this is. Okay. Encryption symmod. Okay. Control primary public key. Okay, these are key material. Okay. Hmm. Okay. All right. No, we're going to abandon this. We're just going to start creating lists and we can verify identity later. Okay. Fine. That's fine. Okay. So create peer DID normal go to. So this was okay. So let's go to the peer DID spec. Let's look at the rest of these demos. Oh, that's it. Okay. Peer DID normal go to. Resolve peer DID normal go to. Okay. Resolves the ID doc. Okay. So how do we have one sign the other one? Multiple inception key without doc. The ability to specify additional keys in the generated DID document. Method is necessary when both an encryption key and a signing key are required. Okay. Service encoding. Okay, example multi-key, peer ID. Okay. Um, how do we, okay. Give a stored variant. Okay, out of band protocol 1. DID exchange protocol. Gauge. DID com. Reduce. Is the user with the browser getting to a point where connection is needed between the websites and enterprise agent? QR invitation is displayed. Scan of protocol is established. Life is good. However, the current invitation process, the same user returns to the same page. The process is executed. A new connection is created between the two agents. There's no way the user's agents say, "Hey, I've already got a connection with you." We need the ability to reuse a connection. Existing connections in DID invitation handling. The inviter dictates the connection establishment. Okay, so handling of out of band. Okay. Okay. Spanish enhancing. Request attached. How do I just make a message happen? All I want to do is link one to the other. Call code. Sender. Receiver. States. Receiver. Messages. Out of band. Invitation. Okay. Okay. Request attach. DID com message type. ID. Okay, so maybe we just need to go into DID com now. Pure DID on the application levels. Okay. So maybe we should go run this. Python demo script. Okay, maybe we just need to do this. Demo. Alright, okay, let's check this out. We may have gone too deep. Okay, DID com demo. Create pure DIDs. Okay. Okay, oh, and here was the stuff that we were just trying to figure out. Okay. Alright, that was a red herring on that. GitHub keys. Okay, so resolve pure DID. Pack. Okay, I gotta stop diving through too much code. Okay. Now we're into DID com. Test media. So I'm confused if DID com uses pure DIDs underneath. Yeah, DID com uses pure DIDs, but pure DIDs use DID com. I'm confused. I think we want DID com. Okay. So secrets resolver, resolver config. DID com service pure DID. Routing keys. Accept. Create. Okay, here we go. Okay. Two hits it. Two. Okay, so we should be looking at this stable branch. This is 2 ahead of main, okay. Okay. Where to use the library secrets resolver and DID resolver interfaces must be implemented. Okay. Anonymous encryption example. Encryption with non-repeat. Build an unencrypted signed DID message. Okay. 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 This is perfect. This is what we want. This. Okay, so we just want to do this. We'll just save it to this format and then we should have. Wow, how many? Oh, geez. Okay. Now we know how to. Okay, so, all right, so encoded manifest. So instead of encoded manifest, what if we did? All right, so manifest equals blank thing for now, and then we'll go down here and we'll try to put the manifest in the body of this message. And so input.id. Okay, yeah, and so we'll use open merge 0.1, 0.1. Okay, from Alice's DID to Bob's DID. Okay, so DID doc. Okay, I'll go to Bob DID. So Bob DID will be, I'll go 1 because we just need to sign to him. Can you join F strings like this? Message. All right, what is this? DID com. Almost like, let's see. Come on, come on, come on, come on, come on. Pack signed. Where's pack signed? We'll assume it's in DID com pack signed. Pack signed. Ah, yeah, that's right. That's all resolvers config. Missing one required argument. Resolvers config. Unpack. This is clean. Okay, nice. Or, well, their API is clean. This is not clean. Okay, so very, very happy if we can make this work. Pack signed, missing resolvers config. Come on. Resolvers config. Come on, come on. Secrets resolver. Secrets resolver demo. DID resolver. Okay, that's coming from this DID resolver pew DID doc. Okay. Let's see. Okay, where's the DID resolver? Okay. Okay, these are async. That's good. So this is where we're going to throw in our data flow, or maybe we'll just say, um, wait, self.source.record DID. I have to go. I think we're close.